In this video, we are going to learn about the X-ray crystallography. When an X-ray beam is passed through a substance, the electrons of its atoms emit electromagnetic radiation in all directions, like that of incident X radiation. These scattered waves from the electrons are arranged in the form of a crystal lattice. So, what is X-ray crystallography? When a beam of X-ray beam is passed through a surface of a substance or into the substance, the electrons of its atoms emit electromagnetic radiation in all directions, like that of the instant X radiation. The scattered waves from the electrons are arranged in the form of crystal lattice. The interference of these waves causes a diffraction by crystal plane. Thus, each crystalline substance scatters like X-ray in the form of its own diffraction pattern according to its atomic and molecular structure. X-rays are electromagnetic waves having definite wavelengths, and the atoms are found in regular three-dimensional structures in crystals. Therefore, X radiations dissolve the atoms found in a crystal, and the atoms of the crystals now scatter the X-rays, thus producing a diffraction pattern in the form of spots. The diffraction pattern thus obtained is recorded on the X-ray film or an electronic detector to determine the structure of the molecule. So, X-ray source will be there, X-ray beams are there, crystal is there, and diffracted X-ray beams will be produced, and detector will be detecting all those diffracted X-ray beams. The study of crystals constitutes crystallography. The crystals are three-dimensional space gratings and are used for diffraction X-rays. When the X-ray beam having continuous range of wavelengths are allowed to pass through the crystal, and transmitted beam is made to fall on the photographic plate. The photograph will show a central spot surrounded by a number of other weak spots in a definite pattern. Thus, the X-ray beam has been diffracted according to the geometrical pattern of the crystal in which the atoms are arranged in a regular three-dimensional lattice. The regular repetition of units in three dimensions is called a lattice, which may contain atoms arranged in many planes. Some planes will have more atoms than the others. When a beam of X-ray is passed vertically downwards on a molecule, there is a partial reflection of X-rays at each plane of atoms of the molecule. These reflected beams exhibit diffraction pattern. Though biological structures are rarely crystalline in nature, X-ray crystallography is the only method to study the structure of these molecules. Here, the biological molecule is crystallized, irradiated with a beam of X-rays, and the diffraction pattern are analyzed. The three-dimensional pattern obtained will indicate the position of each atom in the molecule. The X-ray diffraction spectroscopy includes the following instrumentations, like transmission photographic method. In this method, a tungsten X-ray tube produces a beam of X-rays which is allowed to pass through the pinhole collimator. Now, a fine pencil of X-rays transfers the crystal to be studied. After crossing the crystals, the X-ray get diffracted and are recorded on the photographic plate. X-ray tube will be there, tungsten is there, collimator and the crystal photographic plate will be there. So, X-ray ionization spectrometer. This instrument consists of an X-ray tube which produces X-rays. X-rays are passed through two adjustable slits so that a thin beam of X-rays fall on the crystal sample. The reflected X-rays pass through the slit into the ionization chamber through a narrow aluminum window. One end of the ionization chambers are connected to the positive terminal of the battery, and the negative terminal of the battery is connected to an electrometer to measure the ionization current. The meter measures the intensity of the reflected X-rays. The diagrammatic structure of ionization spectrometer is like this. The X-ray tube will be there, a slit will be there, a crystal will be placed in it, and the slit will be there, ionization chamber is there, so aluminum window will be there. So X-ray tube will be there, slit will be there, crystal is there, and ionization chamber is there, and aluminum window will be there. So rotating crystal diffraction spectrometer. The important component of this instrument are diagrammatically represented. Here the X-rays produced by the X-ray tube are passed through a filter and then through a collimator to form a fine beam of parallel X-rays. The X-ray beam is then allowed to fall on a crystal which is placed on a rotatable shaft. The crystal is made to rotate slowly on a fixed axis in order to cause planes of reflecting positions. The diffraction patterns as spots can be photographed. So photographic plate will be there, collimator will be there, filter is there, and rotating shaft you can see, then X-ray tube will be there. Power crystal diffraction spectrometer. Here the X-ray beam is passed through the filter on the powdered sample. The sample is placed vertically in the axis of a cylindrical camera. After the transversing through the powder, the X-rays pass out of the camera through a small hole in the film and fall in the photographic plate in the form of lines of particular pattern. So powder crystal diffraction spectrometer is of particular qualities. Here the X-ray beam is passed through the filter on the powdered sample. The sample is placed vertically on the axis of the cylindrical camera. After transversing through the powder, the X-ray rays pass out of the camera through a small hole in the film and fall on the photographic plate in the form of lines of a particular pattern. The structures of this spectrometer is shown diagrammatically, and photographic plate will be there, crystal will be there, cylindrical camera can be seen, slits are there, filter is there, X-ray tube will be there. So diagrammatic structure of powder crystal diffraction spectrometer is shown. Next, X-ray diffraction spectroscopy is generally used to differentiate cis and trans isomers and linkage isomers of a complex. The transmission photographic method is useful to study the orientation of fibers and the symmetry of the simple crystals. Ionization spectroscopy is used to study crystalline structures of molecules, while rotating spectroscopy is used to determine the size of unit cells. Powder crystal spectroscopy is useful to study cubic crystals. So it's used to study the cis and trans isomers. It's also used to study the orientation of fibers and the symmetry of the single crystal and crystalline structures and determining the size of the unit cell. Powder crystal spectroscopy is used to study cubic cells.